Hello there, and welcome to video 8 of Module 4, Finding the Slope and Y-Intercept Using Formulas. In a previous video, we explored how you can use Microsoft Excel or other technological tools to find the values for the slope and Y-intercept of the least squares regression line. In this video, we're going to explore some other formulas that could be used to find the slope and Y-intercept. So, you can find an equation of the least squares regression line by using summary statistics and the following formulas. M, or the slope, is equal to R times SY over SX, and C, or the Y-intercept, is equal to Y bar minus M times X bar. In other words, if you know the sample mean for your X values and your Y values, as well as the sample standard deviation for your X values and Y values, as well as your correlation coefficient R, you can use that information to figure out the slope and the Y-intercept for your least squares regression line. These formulas are useful if you don't have access to the raw data from a study, but you do have access to some of the summary values that are necessary for these formulas. So let's apply this to an example. Sergey compares the revenue generated by arcades, X, to the number of computer science doctorates, Y, for several years from 2000 to 2009. The data were collected from this website here and summarized below. So we have our X bar SX, Y bar SY, and our value for R. Part A says to state the correlation coefficient. The correlation coefficient is the same as the value for R. That's what R is. So in this case, R was told to us to be 0.9848. Next, we've been asked to determine the slope of the least squares regression line to the nearest whole amount. The formula that we saw earlier is that the slope is equal to R times SY over SX. Since we have the standard deviations for both X and Y, as well as the value for R, we're able to find the slope using this formula. I substitute in 0.9848 for R, 390 for S sub Y, and 0.23 for S sub X. When I do this, I'm bearing a few things in mind. For example, for my summary values for X, I notice that the label is in terms of billions of dollars. If I really wanted to, I could write that out with all of those zeros, but that's going to be a problem that will plague me throughout this entire process, because if I add in the zeros, for instance here, if I were to add in all of those zeros after 23 to write out billion, 0.23 billion, I'm going to end up with a teeny tiny number that will probably round to 0. So it's best if you have a label like billion or percent, when you could change it to a different value, it's best to use that number label as a label. So I'm going to treat billions of dollars the same way that I treat doctorates. The second thing I'm bearing in mind about this formula is notice that you have SY over SX in part of the formula. If you remember your formula for slope in general, change in Y over change in X, this is in line with that. We have something about Y over something about X. So we still have some of that mathematical background going on as well. In any case, when I simplify this expression, I end up getting 1,669.878261. Because we were told to round to the nearest whole amount, I'm going to round this to the ones place. That's what whole amount means, to the nearest ones place. In this case, because an 8 is in the tenths place, that's going to cause the 9 in the ones place to go up. So I end up with 1,670. My units are my units for Y per units for X. So that's how I ended up with 1,670 doctorates per billion dollars. Part C of this problem is asking us to determine the Y-intercept to the nearest whole integer of the least squares regression line. Earlier, we were told that the formula for the Y-intercept is to take Y bar and subtract m times x bar. Notice that in order to find the y-intercept, we have to find the slope first, because the slope is in the formula for the y-intercept. Fortunately, we just did that in part B, so I have all of the information that I need to substitute in. So I put in 1,195 for my y-bar, 1670 for the slope we just found, and 1.44 for x-bar. Simplifying gives me negative 1,209.8. Because we were told to round to the nearest whole integer, again I'm going to round to the ones place. And again, that 9 is going to have to round up because of the 0.8. So I end up with negative 1,210. Because this is a y-intercept, the label or the units are the y units, which in this case are doctorates. Now you may be saying, how could you have a negative number of doctorates? And that's a good thing to say, because that would mean for this particular problem, it does not make sense to interpret the y-intercept. What this is telling us is that our data is probably going to have fairly large x values that are far away from the y-axis. To wrap everything up that we've done so far, we've been asked to state the equation of the least squares regression line. Previously, we found the values for m and for c, so we found our slope and our y-intercept. And the least squares regression line looks like y hat equals mx plus c. So I just substitute those values in, the 1670 for m and the negative 1210 for the c. As a reminder, when you are stating an equation, you need to state the equation. You're not going to plug in a number for x or for y. Those get to stay variables. You're only plugging in values for the slope and for the y-intercept. Now, because the y-intercept is a negative number, and because adding a negative is the same as subtraction, if you want, you could simply write 1670x minus 1210. Okay, so now that we've found an equation of the least squares regression line, let's use it to make an estimation. So it says that arcades made about $1.734 billion in 2009. Estimate the number of computer science doctorates awarded that year. We're going to round our answer to the nearest whole amount. So I've written down the least squares regression line that we just found. Remember that X stood for billions of dollars and Y stood for numbers of doctorates. Because we are given a billions of dollars amount, we're told 1.734, that means we've been given a value for X. So I'm going to substitute 1.734 in for X. Because we've been using billions as a label, I'm not going to write that as 1,734,000,000, right, with all those zeros. I'm going to keep it as 1.734 because that's how we've been using the data values so far. When I crunch the numbers, I get 1685.78. Rounding this to the nearest whole amount, or to the ones place, is going to give me 1,686 doctorates. In other words, in 2009, when arcades made about $1.734 billion, there were approximately 1,686 doctorates in computer science that were awarded that year. Alrighty, that concludes our video on using summary statistics to find an equation of the least squares regression line. In the next video, we'll be closing up Module 4 by exploring something called the coefficient of determination. Thanks for watching, and have a great day.